So let's look at another example of a separable differential equation here. We want to solve xy times dy dx equals y plus x times dy dx. And now this is subject to y of 1 is equal to 1. So that's saying that we want the solution curve that goes through the point 1, 1. So we want to solve this for dy dx, separate the variables here first. So let's get our dy dx terms on the same side. So let's take this term and bring it over here as a negative. So now we've got the minus x dy dx on the left hand side. So then dy dx is a common factor. Let's factor that out. Here it is. So we take dy dx out of this first term. The xy is left right here. Dy dx out of the second term, minus x left right here. While we're at it, let's do some more factoring. So we got x as a common factor there. So let's factor out that x. So here it is. The y is left right here, and then a negative 1 left in here. So now we want to go ahead and separate our variables. So dy is already on the top on the left-hand side. So let's keep the y's on the left-hand side and the x's on the other side. So we want to multiply both sides by dx. And then divide both sides by x. And then we've got to get this y on the left-hand side, so divide both sides by y. So our x's cancel, our dx's cancel, and on the right, our y's cancel. So we are then left with, on the left-hand side, y minus 1 over y times dy, right here. And then on the right-hand side, dx over x, which we could write as 1 over x dx. So then what do? We've got our variables separated. We integrate both sides. And we got a little bit more work to do on the left-hand side before we can integrate. Let's split these apart over the LCD of y, or if you want, take y up to the top as a negative 1 exponent and multiply it through. So on the left-hand side, we've got y over y minus 1 over y, and then this is just equal to 1, so it's a 1 minus 1 over y. Integral on the right-hand side is all set to go. That's just natural log of absolute value of x, and then we've got our constant. So on the left-hand side, we integrate 1, we'll get y. We integrate 1 over y, we get natural log of y. So on the left-hand side, we've got y minus ln of absolute y is equal to ln of absolute x plus a constant. Notice that this guy here, we can't solve that for y. So we're going to have to settle for what's called an implicit solution. So it's a solution where you haven't solved all the way for y. Because see, if we try to exponentiate to get rid of this log and then this log, we'll have an e to the y over here. So we won't be able to collect all our y terms. So we need to find that constant and then we'll be done here. So we know that y of 1 is equal to 1. That's our initial condition. So you put in 1 for x, you get 1 for y. So we're going to plug in 1 here, and 1 here. So that's going to give us 1 minus natural log of 1 is natural log of 1 plus c. Remember, natural log of 1 is 0. So that just gives us 1 minus 0 is 0 plus c, which is just saying that c equals 1. So now we can plug that back in down here and get our implicit solution. So our solution to the initial value problem, so including the initial condition, is y minus natural log of y is natural log x, absolute value, plus 1, plus our constant. Okay, so solve it like you normally would without the initial value condition, and then at the end you plug that in to get your constant. So now you should be able to try Webassign problem number 3. So why don't you give that one a try.